Okay, here we are in section 6.3, and we're talking about factoring trinomials. Now remember from the previous chapter, we talked about there's binomials, which is a polynomial with two terms, and trinomials, which is a polynomial with three terms, and then we can have like a quadnomial or a four-termed polynomial. But what's going to be important for us to be able to identify for factoring is whether or not a polynomial has two terms, three terms, or four terms, because we're going to have different strategies in each of those cases. Now, we're dealing with trinomials today, so don't get too caught up in trying to keep all this straight. At the end of chapter 6, we're going to kind of put them all together again and talk about, okay, so when you have a binomial, what do you do? When you have a trinomial, what do you do? When you have a four-term polynomial, what do you do in that case? So today we're actually talk about trinomials, and we're going to start off with this, the form x squared plus bx plus c. So this is a special case when the a, so instead of like, it should be like a x squared, it's a equals 1. So 1x squared plus bx plus c, and b and c can be any other numbers. In this case, it has a very unique solution, so we're going to look at this especially first, and then we'll move on to something that doesn't have a 1 in the first term. All right, so the first thing that you need to understand is where these trinomials come from. So here is a binomial times a binomial. We worked on these last chapter. So remember, everything in the first multiplies everything in the second. So in this case, if we were to multiply these two things out, we'd get x times x. And so that would be x squared. And then we'd have x times 2. So it'd be plus 2x. So that was with the first. And now the second, the 5, is going to multiply everything. So 5 times the x is plus 5x. And then 5 times the 2. Now, I know that is 10, but for the sake of this example, to understand what's going to be happening in this factoring, I'm just going to write it as 5 times 2. All right. And then we would combine like terms, and the only two like terms that we have is this 2x plus 5x. So remember, when you combine like terms, you add the numbers, the coefficients, the 2 and the 5 together. And yes, I know 2 plus 5 is 7, but for the sake of this example, I'm just going to say 2 plus 5x, and then rewrite this last one 5 times 2. All right, now I'll go ahead and find the numbers. So this is x squared plus 7x plus 10. And this is a trinomial with the leading coefficient, where the a would be, as being 1. All right, so this middle term, this b term as we'll call it, where did it come from? It came from adding two numbers. And where did this last term, or this c term, come from? Question. So it came from multiplying the same two numbers. So the 7 came from adding 2 plus 5, and the 10 came from multiplying the 2 and the 5. So when we are factoring, we're going to try to figure out which two numbers add to the middle number and multiply to the second number. Now, another thing to keep in mind, let me change my color here. When we're going down this way, so this process that we just did is called distributing. And distributing is taking advantage of the operation of multiplication. So you're multiplying things together. Okay, if we were to start with the trinomial and work our way up into these two factors, these two things that are multiplying each other, this process we're calling factoring. And it's taking advantage of the operation of division. You're pulling things into its part. So keep that in mind. Now, remember when we say like 2 times 4 equals 8 in this case, The things that are multiplying each other, the 2 and the 4, these are called factors. And the 8 is called the product. So what we're trying to do is that we know the product in this case. Now, it's not as simple as 8. Our product is x squared plus 7x plus 10. Now, what factors, what things did you multiply together in order to get that? In this case, it was x plus 5 and x plus 2. So figuring out from product which factors got you there, that is the process called factoring. Okay, so let's look at this one right here. So here it's x squared plus 7x plus 12. Now I know that there were two numbers or two binomial factors, and it was probably x something and x something that produced x squared plus 7x plus 12. All right, so the question is, which numbers were they? Well, remember from the last time, there were two numbers such that they multiply to the 12 and they sum to the 7. So the question is, what two numbers multiply to 12 but they add to 7? Okay, now how many numbers exist that sum to 7? Well, remember we've talked about this several times in the class. The pairs of numbers that sum to 7 is infinite. There's an infinite combination of two numbers that sum to 7. So if we started there, it could be a very long search. Whereas the numbers that multiply to 12 is a much smaller list. For example, 1. 1 multiplies in 1 divides into 12 and it divides into 12 times, and 2 divides into 12 6 times, and 3 multiplies in 4 times, 5 doesn't, and 6 goes in. Oh, but we already have 2 times 6, so I'm not worried about that pair. In fact, if I kept going 1, 2, 3, 4, 5, 6, 7, 8, 9, well, I would just be finding other pairs I found. So 1 and 12, 2 and 6, 3 and 4. Those are the only pairs of integers that are multiplying to, well, I should probably say, of positive integers that are multiplying to 12. Okay, so now, which of these combinations sum to 7? Well, 1 plus 12 would be 13, so nope, it's not that one. 2 plus 6 is 8. Well, nope, it's not that one. Oh, but 3 plus 4, well, that's 7. Oh, so the two numbers that multiply together to give you 12, but then they add together to give you 7 is 3 and 4. All right, so we're well on our way to finding the factors of our problem. Now, let's see. Remember that this 7x came from adding together two numbers, and so we're going to rewrite it as the 3x because we know that now, and the 4x because we know that now as well. So 3x plus 4x plus 12. Okay, so notice what I just did. I rewrote the 7 as the sum of those two numbers. All right, I better put an equal sign out front. Good. Okay, now just like when we were multiplying out the factors when we were doing the foiling, like in this example right here, notice we went from two binomials to 4, 1, 2, 3, 4 terms, and two of them combined to make it a 3-term polynomial. Well, in our example, I went from 3 and I've turned it into the 4. I split the 7x up into 3x and 4x. All right, so now what we need to do is we need to look at the first pair of numbers and look at the second pair of numbers. And what we're going to do right now is factor by grouping, which we've already done in this chapter, so it should be a little bit of a review here. So we're going to factor by grouping. So we're going to look at the first pair of numbers, x squared and 3 times x. Now what number is in common, or I should say what number and variable is in common to x squared and 3x? What number is being multiplied, or variable is being multiplied in both of these cases? Well, the number right here is a 1 and then a 3, so if we say what number goes into 1 and 3, I guess that'd be 1. And then we have x squared and 3x. Well, they both have an x in common, so I'm going to factor out an x. All right, now remember, factoring is taking advantage of division. If I were to distribute this back in, it'd be multiplication, but I'm factoring out, so it's division. And so I'm thinking to myself, what is x squared divided by x? So maybe over here in Scratch, I'll do it in blue. If I take x squared and I divide it by x, it would just be x. All right, so there it is. It's just an x. And then I look at this plus 3x. I ask myself, what is 3x divided by x? Well, in this case, the x is just canceled, leaving me with simply a 3. So it's x plus 3. Okay, that was the first group. Now I'll move on to the second group. All right, what numbers does 4x and 12 have in common? Well, this time only one of them has an x variable, so it can't be an x, but 4. 4 goes into 4 and 12. Now, something to keep in mind, and we'll be doing this, and you'll see why this is important as we do more examples, but the first number is a positive 4, so I'm going to factor out a positive something. In this case, it is positive 4 itself. All right, and now we do that division again. So 4x divided by 4 is just the x. So I leave an x. Well, I should probably do that in blue just to be consistent here. X. And then the 12, let me do it down here. 12 divided by the 4 is 3. So x plus 3. All right, now I factor by grouping. Okay, now we went from 3 terms to 4 terms. We factored by grouping, and technically there's only 2 terms sitting here. There is an x times x plus 3 and a 4 times x plus 3. So between these 2 terms, this x times x plus 3, 4 times x plus 3, what do they have in common? And I've highlighted it here already in blue. Both these 2 terms have an x plus 3 in common, so I'm going to factor out an x plus 3. And then what remains behind? Well, you can see it. It's just sitting right there as an x and a plus 4. So x plus 4. All right. Well, I think we have it. We started with a product, x squared plus 7x plus 12, and we found the 2 factors, the x plus 3 and the x plus 4, that were multiplied together to get this thing. Now, if we wanted to check, what would we do? Well, we could just FOIL this whole thing out, multiply this whole thing out. So we could say x times x is x squared, x plus 4 is plus 4x, 3 times x is 3x, and 3 times 4 is 12, so it's x squared, oh, almost lost it there, plus 7x plus 12, which is what we had originally. So this problem checks out. Okay, so this is the first example, and because it's the first example, kind of lots of extra things got said. So let's just do another one real quick, and this time let's streamline the process and just focus on the problem itself. All right, so here we have x squared plus 5x plus 4. So again, we're looking for 2 numbers that multiply to 4, but they sum to 5. So remember, let's start with the multiplication first. What numbers multiply to 4? That is a much shorter list than all the numbers that sum to 5. So 4. Now, myself, I mean, maybe you're already looking at this and you say, I know what the pair is. Well, that's good. And if you figure out just by thinking about it without having to list them all out, if you could figure out what two numbers multiply the 4 and they sum to 5, then by all means grab it and run with it. Myself, I've never really had that intuitive sense of being able to find them. I always had to be very systematic about it. So I would say, well, here's 4, and I just work down the list. 1 goes into 4, 2 goes in 4, 3 goes 4, nope, 4 goes in 4, and then I just work it out. Say 4 divided by 1, well, that's 4. 2 divided by 4, 4 divided by 2, that's 2, and that's my list. Okay, and then I look at my list and say, okay, which one of these sums to 5? Which in this case is going to be the 1 and the 4, because 1 plus 4 is 5. All right, well, then I'll rewrite my trinomial with those terms. So it's 1x and 4x. So again, I'm just taking my 5 and I'm splitting it up into those two numbers I just found. So then plus 4. All right. So now that I split up the middle term into those two, I have these pairs, x squared plus 1 and 4x plus 4. And now I'm going to factor by grouping. So what number or variable goes into both x squared and 1x? And the answer is x itself. That's all. And that leaves me with x plus 1. Okay, now I ask myself, what two numbers or variables go into 4x plus 4? And because my front number is a positive, I'm reminding myself that I want to pull out a positive number. And the answer is 4. 4 goes into 4x and 4 goes into 4. So I'm going to pull out a positive 4. And then 4x divided by 4. Well, 4 divided by 4 is 1, so it's 1x. And this last term, 4 divided by 4. 4 divided by 4 is 1. So there we have it. And now we have our two pairs of numbers. I have the x plus 1, which both terms have in common. So that's one of my pairs. That's one factor. And then I have my second factor, and you can just see it. You can just see it sitting right there, x and 4. So my last factor is x plus 4. All right, do I have it? Well, I can always check. So let's see. X times x is x squared. X times 4 is 4x. 1 times x is 1x. 1 times 4 is 4. And now x squared, 1 plus 4 is 5, 5x, and plus 4. All right, that's exactly what we started with, x squared plus 5x plus 4. So indeed, those are the factors.